and welcome to a new episode of the Computomics podcast. My guest today has over a decade of experience in bioinformatics. Career stops include heading a state-of-the-art sequencing facility for applied bioinformatics at Wageningen University in the Netherlands, being the CEO of Gene Twister Technologies, and since 2020, he's embracing a new challenge as Business Development Director at Hudson Richer Biotechnology. Gabino Sanchez, welcome to the podcast.
Thank you very much for having me.
It's a pleasure. Gabino, can you tell us what's your role exactly at HRB, at Hudson Richer Biotechnology?
Well, as you said, the Business Development Director, basically, I am trying to connect Hudson River with the different possibilities for business in the different segments. The technology in which we are developing, gene editing for plants, allows you to reach all kinds of segments. So from the vegetables, cereals, field crops, ornamentals, but also from other industries like forestry or many different industries. My role is make these connections and make the people aware of the possibilities of the technology. Let them think about, what can we do next year? Or how can we impress our customers? And how can we make this technology really make a change in the way we do things in the business? And it's a very, very exciting job that I'm doing.
Mm-hmm. You mentioned the different technologies and making people aware of them. What would you say, what are the core solutions of HRB?
So that we have two main solutions. Mostly where we started was the gene editing using CRISPR enzymes to actually modify the genomes of plants and make them adapted to the consumer demands or for the farmer demands. That is the main technology. But the second one that we are launching this year are basically a smart delivery system for agrochemicals. So we are able to make that agriculture is way more sustainable, lowering the amount of active ingredients that we are talking about, for example, like fertilizers or pesticides, and make them in a more sustainable way. And that's the other technology. We call it the plentrans molecules, and we think they're going to change also the way that agriculture is basically having an impact on the environment.
Interesting. Can we go a little deeper on that? You said it's a smart delivery system. What can I imagine as someone who's not from the field?
Yeah, you can imagine, for example, if you think about how people spray, for example, a pesticide, for example, into a field. You have this image of the farmer using some sort of device to spray, or you have these planes having these clouds that deliver the agrochemical. The problem with this type of sprays is that in order to achieve the goal, you need to overspray, because most of the active ingredient or a pesticide or a fertilizer really runs off or evaporated, or is when yours release is basically removed and is not reaching the plant. What we do is basically encapsulate the active ingredient in molecules that make them really, really targeted towards the plant. And in our case, our molecules are very special because they are able to go through the plant cell wall. So the effect of the active ingredient actually happens only inside the plant. And we made this so specific that it's actually not harming the environment. And they are biodegradable, so actually they are not accumulated in the environment, and it's very safe what we have. So we have a very good product,
Yeah, that does sound amazing, because I mean, it sounds like you obviously save or help save the impact on the environment gets lessened, right? And then also, I would assume it also impacts the purse of the farmer in question, right?
Well, there are two aspects there, yeah, indeed. So in one case, we are aiming to lower the amount of active ingredient, for example, that goes into the field, and we're talking about one order of magnitude less. So that's one. So the impact on the environment is less. You have to spray less. But the second one is, as you say, the amount of active ingredient that the farmer has to buy is way less because they have to spray less. So it's cheaper for the farmer. And at the same time, it's less problematic for the health of the farmers or even the consumers, because the less product you have on the field, less product that is consumed by not only the farmers, but also by the organisms that live around the field.
For sure. And what would you say, what do you enjoy most about your work specifically in explaining these technologies and making those connections?
To be honest, is as you see now, is that, I really believe that this is going to change the agriculture and how people really in the food chain is gonna use the technology CRISPR in one sense, and these particles in the other side, making them think along yourself. Many of the people in the industry have been working for a very long time, and they just say there are new possibilities that you didn't think about, and make them dream something different, and brainstorming together with them. That's what gives me the energy.
Mm-hmm. How do you make them dream? Do you explain, just like you now did, kind of the advantages, or what's your approach there?
Yeah, and indeed, I try to give them some examples, what they can do with it, because at the beginning they come with their own ideas, and some of them are amazing. But sometimes when you come with your own suggestions, sometimes they're like, wow, I didn't think about that. And then you see in the eyes, that they're sparkling, and there is something in the back of their minds maybe they want to share with you, maybe not, but maybe later. And at the end of the day, you end up with this, complicity. You start to talk about possibilities and brainstorm, and it's a very, very, it gives you a lot of energy.
I bet. Now, we talked about the smart delivery system, where you deliver the agrochemicals with molecules. That's when the plant is already grown, right? to try and get more of a yield, I guess. But you also mentioned CRISPR, so that would, I guess, qualify as a technology that's more geared towards optimizing plant breeding. Can you go into a little more detail how you approach this through technology?
Well, since the moment that the CRISPR technology appears, it was a clear breakthrough in science. The possibility of actually editing the genome the way you want it. You have to put a little bit of context and perspective on how things have changed. When you're working in the breeding industry for a long time, you know that the companies are looking for satisfying the customer needs, creating new products, and the way to do that is through generating variation in the genomes of the plants that they're working on. So you can generate plants with more, let's say, consumer traits, more desirable traits, or also from the farmer's perspective, that they have agronomic traits that makes them more productive, so more yield, more resistant, less input in terms of fertilizers or in terms of pesticides. So all these type of things makes the plants better, and for the farmer's perspective, and also for the consumer. The way that the farmers were doing, or breeders were doing, the introducing genetic variation was very, very rough methods. And we can talk about the ones that they are actually approved. And many of the varieties that you see now in the supermarket, the way that this generation, the genetic variation has been introduced is really like with a hammer. So sometimes, with some systems some methods that has generate random mutagenesis or crosses with the different, not so appealing varieties, and so it's complex. It's complex to generate this variation in the genomes of the plants of interest. So imagine that you have a technology that instead of using the hammer, you're going with the sniper gun. Go to that place in the genome that you need to change, and that's something that we know from years and years of cumulative literature, knowledge from the field. We know what's going to happen, and we know that there are no side effects. So we know exactly what's going to happen if we change one thing. And you just do that. You just change that thing, and the system now allows you to change only that thing and nothing else in the genome. So if you have a top genetics plant that is working fantastic in the market, what you don't want is that plant to cross it with something else and lose part of the value that this plant has. With CRISPR technology, you just basically change the gene of interest, and you have a plant which keeps exactly the same top genetics, only changing the gene that you want to modify. So that opens all kinds of possibilities, because you do not only can change one gene now, you can change several genes at the same time. You can introduce several traits at the same time. And the other thing that makes it amazing is that when I'm talking to you about, when breeding companies think about launching a product, we're talking about 10, 15 years.
Yep.
And that is a very normal breeding cycle. With CRISPR, we are talking about months. You send me the plant today, and in less than a year, or maybe a year and a half, we are talking about, here is your plant ready for going back to the commercialization phase. So that's a game changer. It's a game changer for many companies, because then the time frame to introduce new characteristics has been dramatically decreased from years and years to months.
Yeah, that's a warp jump, if you will.
Exactly.
And I know you also work with Computomics or know about Computomics. Yeah. How did you learn about the company?
Well, I was attending one of the showcase, the Innovator Showcase in UC Davis, and then I learned about them, and I was very interested about the technology that they were developing. And to be honest, I was very impressed with the results. And Hudson River is a company that is specialized in CRISPR. So we were not, internally we were thinking, should we develop some sort of a way to identify the genes that we need to edit, because that's at the end of the day, we need to edit something, but we need to know what. For many traits, it's known. For many other traits, it's not known. So then we were thinking about, okay, should we develop internally our capacity for identification of? Because we say, the smarter thing to do would be to partner with a company that is doing it. In who is the best? Computomics came immediately into our radar, and that's why we started to talk about possibilities of combining forces between what Computomics can do and what we can offer. Which is, I think, we think we offer the best gene editing platform out there right now.
And can you describe in a little more detail how the partnership evolved? Because it's been a while, right, since that first kind of seeing Computomics at the UC Davis Innovators Showcase.
So we started talking about how to create the concept, the synergy between both companies, and we started to have this product that goes from end to end, from the needs of the consumer. We're talking about breeding companies that they are really interested to introduce a trait, but there is not really information regarding which genes are involved in controlling that particular trait. And us bringing out the latest technology to validate the candidate genes the fastest way using our target with our gene editing workflow. So we started to think about, okay, how can we combine forces? And then immediately was a click. And we were brainstorming about how to position in the market. There was clear opportunities all over the place. Many companies were interested in the traits that they know that will bring a lot of value to the company, but they are not know which genes are involved. And then we can not only predict which one will be, we are going to validate which ones are going to be. So we open immediately the market opportunity. And we came up with a name of this opportunity. It's called AccelATrait, which captures kind of the synergy of both companies. And we think that we will bring traits into the fastest development phase to many companies.
Now you already almost smelled what my next question was going to be, namely, what is that combined solution or that collaboration effort? AccelATrait, great name. Mm-hmm. Can you explain a little? What is that joint solution?
So the idea is that as AccelATrait, which by the way was coined by Sebastian. That's how it works. The idea is that companies come to us with a demand of which trait they need to introduce into their germplasm. And they don't know which genes are involved there. How are we going to do anything about it? So then Computomics come into place. They set up the machine learning methods and start to understand which reconnections are between genes. And they find out, they highlight a list of candidate genes that they are very likely involved in the trait. But then comes the next part, which is once Hudson River learns about this information, we use our gene editing platform to validate which of the genes are actually involved in controlling the trait. So the outcome will be plants that already has controlled the trait. And the customer comes from knowing nothing. Suddenly they have the plants already with the trait already controlled, which is a very, very great advantage from what it is right now, which is they don't know anything about it. So they don't know what to change.
For sure. And you said so expressively before with the CRISPR process, the difference in time that applying that new technology, that breakthrough technology brought to basically everyone involved in the process. What can if I were a client coming to you with a plant that I want to improve and I have no idea about the traits or just a rough idea, what can I expect? Like, how long does it take between this initial contact and some sort of result, or like maybe there are a few steps?
Yeah, well, this is a very good question. I mean, depends on the trait usually. There will be very complex traits in which we're talking about maybe hundreds of genes to be involved, quantitative traits that they are very difficult to pinpoint the causal gene there. That will be a difficult, these are not the type of traits we are talking about. We're talking about more traits that they are qualitative, the absence and presence of several genes, 1, 2, 3, 5 genes. That is the type of things that we can discuss. We have to be clear about expectations with the clients about which type of traits are we talking about. But definitely we can deal with these type of traits. And the idea is that with Computomics, together with us, it will take, we are talking about between 2 years, less than 2 years, you can have these plants back with the trait. And that is the time frame that we are talking about, which is, again, from knowing nothing about the trait and having the plant in your greenhouse growing with the trait. Well, I think it's a very interesting proposition.
Certainly fits the name AccelATrait. Certainly seems to fit. That's crazy compared to the 10, 15 years you were talking about earlier, right?
And that is sometimes you can't. I mean, and this is the other thing. You know, with editing, we found that now we are talking with many industries in which actually you don't even think about introducing certain traits, because the amount of combination of crosses that you have to do, or the variation in the genome that you have to introduce, is so huge that it is not really possible to do it. And editing offers you the possibility to dissect the genome, allows you to change something, and then get the change there. So it really has dramatically changed the way of operating. And of course, comes the second part, which is whether it's allowed or not.
Can you go into more detail on that?
Sure. The question is that each country basically has a different policy regarding what happens with edited products. The idea is that, as I'm telling you, it's a very different concept, editing, compared to generating a genetically modified organism with these rough techniques. When you modify a lot of the things in the genome and you don't know what's going to happen, I fully understand that. There is a clear concern from many different stakeholders about what's going to happen with these plants. I understand this valid concern. But when you're talking about the technology that basically changed one thing, one gene, one piece of the gene and nothing else, and you know what's going to happen because you know you have backup from the literature, from the science that has been developed for many years, that is a very different type of concept. So we are trying to see whether the legislation puts these things in different places. And the regulation is being at the EU level, for example, in Europe. Right now, it is not allowed to commercialize edited products, but countries around Europe, like Switzerland, now the UK, is coming into place. They're starting to think that edited products are actually a different thing. It actually shouldn't be labeled the same thing as genetically modified organisms. And other countries, and if you go to the US, and you go to Australia, you go to Southeast Asia, you see that the regulations are allowing more and more the use of editing as a way to improve plants. And the products that come out of that are now commercialized in these countries. So the question is, it becomes a little bit asymmetric, not in terms of competitiveness. Europe, or the countries that they are not allowing the edited products, versus the one that can in months bring new traits into the market. That poses a little bit of different speed for competing between breeding companies or vegetable companies here in Europe compared to somewhere else. So
what would you say as a kind of future outlook in the next coming years? Would you say that how can we tackle that challenge? And because there are different stakeholders involved too.
Absolutely, and you have to be very, very careful about how you approach this. And I think as I'm saying, I think you have to come up with the scientific arguments of why do you think that this technology really can benefit the consumer at the end of the day. And you have to bring bring along very good examples of how this technology allows the consumer to have products that they are longing for a very long time. And we are talking about, for example, products that has consumer traits like allergy-free products, things that they are not allowed, they are not possible through normal breeding or conventional breeding. Using editing, you can do these things. And having them in a very short period of time available for the consumer, I think we should position the editing products as the next generation for the consumer to have the products that they're looking for in a very short period of time. This is one aspect. The second aspect, which in my opinion is even more important, is that edited products or the edited plants will make the sustainability possible. And I think that's why sometimes we need to stress even more that. I think edited products will make the plants way more needing agricultural inputs. So that will make the plants way more resistant to climate change, being able to still produce the amount of food that the society is demanding, but less fertilizers, less pesticides, and way more easier for the environment to grow these plants. So we need to, and this is possible, and it's possible to do it in a very short period of time. Because if you're waiting for the conventional breeding or molecular breeding, we're talking about 10 to 15 years. Do we have time for that? Maybe not. Using editing, you can really shorten that period of time and making the plants really coping with the challenges for sustainability and for making the environment really, affordable, at the same time meeting the demands from the consumers, because we are not going to eat less. We're going to eat more. We are more people. So we have to be pragmatic about these things. And in my opinion, but that's my opinion, of course, I think editing probably is the solution to allow even organic farming to be possible and be feasible in the time frame that we need it.
Maybe it will become easier too when there are, a few more years of that technology in the market, of people actually consuming plants that were edited. And so there's data to show that they aren't posing a danger, because that's the argument that very often comes. We don't know what this actually does, right? We don't know how this actually impacts our bodies or anything. And if you've had that, I guess we always have that, and to a certain extent, it's understandable. With every new technology, there's skepticism, and there should be. It's healthy to be skeptical.
Absolutely, but that's why we have to have. That's what I'm saying all the time. I talk to the students, for example, at the university here many times, about let's have a rational discussion based on facts, on science, and this is what you have. This is what the legal framework says about possible foods that can go to the supermarket and foods that shouldn't go to the supermarket. And if you are okay with these type of things, why you are not okay with these type of things? And that's having a coherent policy about what is okay to be on your table and not, I think is a very important discussion to have. And as I'm saying, when I'm talking about from the, you say, we don't know what is the impact of these changes. Of course, this is the first thing that you have to do. But that's why it's possible to bring traits that they are very well known what the effect is, and say, hey, now you have a product that comes to the market very, very quickly with the safeguards from the knowledge that we have accumulated for years and years and years. So yes, it's possible. One of the things, for example, this is a very good point that you're making. The technology has some sort of uncertainty when it has been applied at the beginning, because when you were editing, there is a thing called off targets, which is sometimes your nucleus, the enzyme that actually edits the genome, has not only targeting the gene of interest, sometimes goes somewhere else and do something else. That has been one of the complaints many times. But nowadays, the technology has matured enough to not have these off targets. We sequence, for example, the plants that they are coming out of our workflow, and we assess before and after, and we see that they are not off targets. So it's only that part of the genome. So the point is, when you are, as I was saying before, when you are talking about generating variability for your crop using the conventional methods that they are allowed, that they are legally allowed to generate variation that way, we are talking about thousands of changes in the genome, and that is allowed. Okay, and I will raise the question, but these thousands of changes are very difficult to predict what changes each of them have in the plant at the end, in terms of environment, in terms of their health. Thousands of changes to follow is very difficult. I'm talking about one. I'm talking about technology that brings only one, and it's extremely well documented what the changes are. So I think when you're talking about a framework to approve these type of products, I think there's a way safer pathway towards the deregulation of these type of products.
Certainly a very strong argument that you make here. We will have to see how this actually is applied in policy making in the coming years. Gabino, thank you so much for taking the time to talk to us about these things. It was a true pleasure. Yeah, and to our audience as well, I hope you enjoyed it as much as I did. We learned quite a bit about the HRB technology, including smart delivery system to decrease agrochemical levels in plants, the CRISPR technology, and then especially interesting for us as we're in the Computomics podcast about AccelATrait, where HRB and Computomics kind of united their strengths to find ways to identify potential traits, interesting traits, much, much faster than you could with other methods. Thank you so much for your time, Gabino. And to our audience, I look forward to having you for the next episode. Meanwhile, feel free to check out computomics.com. You'll have some notes on this episode as well as the others that we have done before. And I look forward to being with you again in the next episode. Bye.